Welcome back to College Algebra, MAT 150. In this lecture, we will be going over intervals of increasing and intervals of decreasing. So a function is increasing on an open interval a to b if, going from left to right, the graph is going up for the whole interval. A function is decreasing on an open interval if, going from left to right, the graph is going down for the whole interval. And we say a function is constant on an open interval, again going left to right, if the function doesn't go up or down for the entire interval. And those are, in fact, our intervals of increasing and decreasing. And we could have multiple ones on the same graph or the same function. And the way we would sort of glue those intervals to find all of the intervals of increasing and decreasing would be through a union symbol. So let's look at each one of these below. So for the first one, we're going to try to find, so for all these, we're going to try to find intervals of increasing and decreasing. And for this first one, I'm going to notate this over here. INC for increasing, and it's intervals of increasing. And we have to go from left to right, the graph has to be going up. Well, as we go from left to right here, then the graph is going down. So here to here, the graph is going down. But from here, from 0, so again, it's about, so the intervals we're looking for are along the x-axis. So where are we increasing? When we go from here and up, the graph is going, or not here and up, here to the right, more positively, the graph is going up. So where's this x value? Where it starts going up? 0. So we put 0 there. And again, these were always open intervals, meaning that they get parentheses. And then how far and how long does it keep going up? Well, to infinity. So as we go out forever. So 0 to infinity. What about decreasing? So we're going to indicate that with DEC. Well, where's the interval decreasing? Well, that's on the other side. So from the arrow, again, we're talking about the x-axis. So when we're all the way out here, we have this arrow. It's going from left to right. The graph is going down. So on this interval here, all the way out to forever, it's going down. So we go, when we're dealing with intervals, we go from negative to positive, going from left to right. So negative infinity to 0. And that's our interval of increasing, and that's our interval of decreasing. Again, they have to be open intervals. We don't want to actually include that number. What about for number 2? So adjusting this over. So we're going to do the same thing. We're going to try to find an interval of increasing, an interval of decreasing. Could be more than one interval, to be fair. So as we go from left to right, do we ever see it go up? Well, the only place, well, the graph doesn't start until right here. So it doesn't start until right there, but as you go from left to right, it's always going down. So we don't have any intervals of increasing and decreasing. So I put like a little circle with a dash through it, a vertical or a diagonal dash this way, and that represents the empty set. There are no intervals of increasing. But decreasing, well, we start at -1. Again, we always put parentheses for intervals of increasing and decreasing. So -1 all the way up to, again, going from left to right. So here to out here forever, -1 to infinity is the interval where the graph is decreasing. All right, example 3. Let's look at intervals of increasing and intervals of decreasing. So again, going from left to right, is the graph going up? Well, for the most part. However, what's interesting here is it looks like it gets flat right here. And where it's flat, where it's not increasing or decreasing, we don't include those points. So it's increasing from negative infinity up to 0. And then again from 0, again it's at 0, it looks like it's flat, from 0 to infinity. it's also increasing. And since it's always from left to right, it's always either going up or it flattens, then we say that there's no intervals of decreasing. None is also a sufficient answer. All right, what about this one? So increasing, going from left to right. So again, all the way out until we see this. Oh, it peaks up here. Oh, okay. But so from here to here, going from negative infinity up until 0, in this interval, it's going up. But then going down, it goes down from here out to here, so that's from 0 to infinity. We have some more examples. What about something like this? So here it says we have this graph. So where is it increasing? Again, going from left to right. So the interval that we care about, it's increasing. The graph is increasing until we get to here. And then from here to here, it's decreasing, it looks like. And then from here on, it's increasing again. So we would write for the interval of increasing and decreasing. So it's increasing from negative infinity up till negative 1. And then we also have increasing from 1 up to infinity. Similarly, for decreasing, well, not that similarly, but for decreasing, we go from negative 1 to 1, where it's decreasing going from left to right. So negative 1 to 1. All right. And for this last one, number 6, let's look at the graph. So all the way out here, so we always start here. Along this interval, is the graph going up or down? Well, it looks like it's going down until about right here. And then from here to here, it appears like it's not moving up or down, and that's a constant interval. And then from here on, it looks like from here until the arrow, which means forever, it's decreasing. So are there any increasing intervals? Intervals of increasing? None. So intervals of decreasing, we have negative infinity up till negative 2. And then we also have from 0 to infinity. So if it's not increasing or decreasing, we have a constant interval between negative 2 and 0. It doesn't ask, the problem doesn't ask for this, but that is what's actually going on. That concludes this lecture.